one situation we know about the orientation of the object from the other devices like a camera. So let's say we have a camera there and we have an arm here. So and then we have the object at the near to the arm like this. Okay. So we know the situations or the metrics or the informations of the object as well as part of the arm. So how are we going to know about the orientation of the object according to the arm? So in this video I will discuss about how to solve the problem for the orientation base of the object. Okay, and know the homogeneous transformations between the robot arm and the center of the object. So let's take a look.
Okay, in this method, we have two ways to determine the HTM from the base to the targeted object. Okay, so the first method is a calculation method. The second method is a graphical method, which is the calculation methods using this formula that counter the camera to base and camera to box. Okay, all right. For the calculation method, so we go straight to the problem and the situation here. Okay, let's say we have this platform which is the camera is given with these orientations axis, and we have an arm here with a base here and the box, the targeted object that we want this arm to pick. Okay, so the camera has focused on the box and already get the information regarding the box HTMs. So here we can have the HTM for the camera to the box we label as a T1, and we have a camera to base of the robot that we label as a T2. Now our mission is to get the T3. Alright, so according to the first question A, what is the position of the center of the cube with respect to the base coordinate systems? Okay, it means that we need to find the HTM for the box that based on the base of the arm. Alright, so okay, let's take a look on the calculation method at first. Okay, by using the calculation method, so we have an equation as I mentioned previously, which is T1 is a cam to box for our situation here according to the problem given, and T2 is a cam to base. So we want to get the base to box matrices, which is base to box can be calculated by multiplying the T2 inverse with the T1. Why inverse? Because when inverse the T2 we can get base to cam. So when base to cam multiply with the box to cam, so then we can get base to box. So cam to box is already there with T1, but for the base to cam we need to inverse the T2. Okay, so by using the matrices method, so we can get the full matrix for the T3, which is a base to box matrix. So here we can already get the orientations or the HTM coordination for the box that based on the robot base coordinations. Okay, so how about the graphical method? So in the graphical methods we need to extract the orientation matrix and the position matrix in the each HTM of the orientation matrix given. For example, for our case it's a T1 cam cam to box, and T2 is cam to base. Alright, okay. So in this method we have two steps. First one is orientation determination, and second one is position vectors determinations. Alright, so we go to the orientation determination first. It's going to be a bit easy to go at this part. Okay, let's say we go back to the figure. We have base, box, and a cam, and remember the cam is already given with the orientation position or axis, y at this point, x at that point, and z on the below. Okay, so this is the notification of positive of the orientation for this camera. Okay, so we go first on the R1, which is cam to box. We want to get the orientation or the axis of the box first. Okay, from the matrix we can tabulate the matrix into this table. Okay, then we can know the orientation of the box. So the first step, we need to find the coordination with the numbers. Okay, I means the value, that non-zero values. Okay, so for this case we have coordination between x and y for the box to cam, and x box to y cam, and here we have a z box to z cam. Alright, so the first part is we want to determine the x box to y cam. So x box to y cam is positive. Alright, it means that the box is following the y positives of the camera. Okay, so for the x box is positive here. Okay, so we can draw the positive arrow here, and for the y box, so the y box is following the positive of the x cam. So it means that we need to draw the y box positive here, and then lastly we have z box between z box and z cam. So the z box have a different position, different poles compared to z cams. It means that the z box is upper. Alright, so and then for the base orientation we need to get the base to cam matrix, and we tabulate like this. Alright, so here, so the same thing we repeat as orientation of the box. So we need to find the non-zero coordination between these these two items. Okay, so for this case, the first one, we find that x base and x cam have the same poles. Alright, so we can draw x positions, or the positive of the x for the base like this. Okay, at this arrow. Okay, at these poles. Okay, so it means that the positive base of the arm should be at this point. Okay, and then another one for the case of y base and y cam. So they have different poles, which mean that for the base should be different poles if compared to the cam here. So the cam here is on the front, and base here is on the back, according to this view. Okay, next with the z base. Okay, the z base is different also. So it means that the z base for the base of the arm is on the different poles. I mean the reflect. Alright, so it should be in the it should be above, compared to the cam will be at the bottom. Okay, so now we get the orientation for the base and orientation for the box. Okay, so the next step will be to determine the orientation of base to the box. Alright, So now we can draw the table for the base and box coordinations. Alright, so the first step, we check for the X box. Where is the X box? So actually the X box is parallel with the Y base here. Okay, as you can see, so these two, okay, these two is parallel each other but at the different poles. Okay, so we notify that here the value is a -1 between the X box and the Y base. So how about the Y box? So Y box is a parallel with the X base here, and is like the same poles as a X base, so it makes that the Y box and the X base is 1. And how about the Z box? Okay, the Z box is also parallel with the Z base and also at the same poles. That makes the Z box is 1. So the others empty box will be 0. Okay, so now we can have base to box orientation matrix. Alright, so we go on the next step in determine the position vectors of the matrix, because the HTM, they consists of two important matrices, the orientations and the position vectors. Alright, so for the position vectors, in this case we need to extract the position vectors as I mentioned previously for each cam to box matrix and the cam to base matrix. So we notify for the position matrix for cam to box as a P1 and cam to base as a P2. Alright, so we go back to the figures. So here from the matrix of P1, so we can know the coordination of the cam to box coordination, which is we can draw that this position like this, and then we can notify as this for the X positions, and this one is for the Y positions, and then this one is for the Z positions. Okay, between the cam to box. And how about the P2? P2 is cam to base, so we can draw cam to base like this. Alright, so negative means that back, okay, at the back of the X of the camera, so -10 and +20s, and below is +10. Okay, because they are follow the cam the cam poles. The cam poles here is positive, not following the base poles. Okay, so how about between the base and the box? Okay, firstly we need to determine the px. Okay, px for the base to box. Okay, so here we can see that the coordination involved here is the y coordination of the cam to box or P1, and x position of the P2 and x position of the P1. So it makes that we can have these two plus summation of these two, so the px become 11 here. Okay, so how about the py? Okay, py is a coordination for the base to box at the y axis. So at this point, okay, what's the involved is the p1 the p1 values. Okay, so p1 values here, okay, and the p2 values here. So between these two, okay, is actually the position of py is minus of between the P1 P2 and P1. Okay, so here we can mix that the cam to base minus with the cam to box, so it will make the PY is 10. Alright, so how about the PZ? So PZ is like below of the origin of the box coordination or box orientation. So it makes that this PZ for the base to box is minus between the 10 here, base to camera, and box to camera value here, right? So it makes that the PZ is 1. So this is a position vectors of the base to box matrices. Okay, so lastly we can summarize that the matrix orientation for the box with respect to the robot base can be determined with this matrix, okay, which is so base to box at this area, and position vectors at this area, which is the matrix value is same as the calculation method, but it takes a little bit steps if compared to the calculation method. Okay, it depends on the person's whether want to use a calculation method or the graphical method, because some of the people like to use a calculation method because they are good in mathematics, and another person is good in logic, so they prefer to use a graphical method. Okay, so how about the solution for the question B? So I think I let this one for you to think about it and try to make it by yourself. So I think that's all for this video. Thank you very much for watching, and don't forget to subscribe, and also please follow my videos because they have a lot of next videos incoming for you to view, and I hope this video will help you a lot in your current task and current learning. Thank you very much. Assalamualaikum.